After downloading the source code of both kernels and decompressing them in this folder, and I type ls, both kernel folders will appear inside this folder. Here I type the sudo make menu config command for the Linux 4 kernel, and the configuration file is created. And if I do the same thing for the Linux 5 kernel, both kernels will have their own configuration file. This is where I build the two kernels. You can see that some commands can be ran in parallel when building the two kernels. But the sudo make install command must be ran one kernel at a time when building the two kernels. This is where I modify the grub file. And then I update the grub with the sudo update grub command. Then when I restart the virtual machine, both new kernels will appear in the grub's kernel list. If I choose kernel 4.19.148 when restarting the virtual machine, I can read the corresponding kernel version in the terminal. This is the same for kernel 5.13.19. The following screenshots, number 6 to number 9, are actions performed in the kernel 4.19.148 folder. This is the content of the echo test folder we created. This is the content of the echotest.c file. We defined two new system calls, syscall test hello world and syscall test echo. They print messages into the kernel lock buffer using the printk function. This is the content of the make file in the echotest folder. This is the syscall table file before we modify it. And this is after we modify it. Two new system calls, syscall test hello world and syscall test echo with IDs 548 and 549 are added to the file. This is the syscalls.h file after modification. Signatures of the new system calls are added. Now for screenshots number 10 to number 13. We repeat the same actions under the kernel 5.13.19 folder. We have the echotest folder, the echotest.c file, the make file in the echotest folder. This is the syscall table file before modification, and the file after modification. We added the same hello world and echo system calls, but their system call IDs are 554 and 555. And this is the syscalls.h file after modification. Then we rebuild both kernels. This is the successful result of the sudo make install command for both kernels. Now, I restart the virtual machine and choose kernel 4.19.148. Then I create the syscalls hello echo.c file and build and run this program. We can see that since system call IDs 554 and 555 are undefined in this kernel's folder, they will return -1 when called, which indicates an error. And in the kernel lock buffer, messages printed by system calls 548 and 549 are displayed. I restart the virtual machine and choose kernel 5.13.19 this time. And when I run the program, system calls with IDs 548 and 549 will return -1 because they are not defined in this kernel's folder. And in the kernel lock buffer, messages printed by system calls 554 and 555 are displayed. This is the numerical test.c file for kernel 4.19.148. We define 4 new system calls, return individual values, minimum, maximum, and data types. And this is the numerical test.c file for kernel 5.13.19. We also define 4 new system calls, return individual values, addition, multiplication, and data types. Again, screenshots number 19 to number 21 are modifications to files in the kernel 4.19.148 folder. This is the newly created makefile in the numerical test folder, and the modified makefile in the Linux 4.19.148 folder. This is the modified syscall table file. I added 4 new system calls with IDs 550 to 553. And this is the modified syscalls.h file. Signatures of the new system calls are added. Screenshots number 22 to number 24 are modifications done to the files in kernel 5.13.19 folder. This is the newly created makefile in the numerical test folder, and the modified makefile in the Linux 5.13.19 folder. Again, I add new system calls with IDs 556 to 559 to the syscall table file, and add new system call signatures to the syscall.h file. After rebuilding both kernels and restarting the machines, I now run this C program in kernel 4.19.148. I already compiled it, so I can go into the terminal and start running the program. This is the run results. And these are the messages printed to the kernel log buffer. Now I run the same program using kernel 5.13.19. These are the run results. And these are the messages printed to the kernel log buffer.